Hello everyone, this is a look at my iced project in Rust. So it's an SSH client written in Rust with iced, the iced library for creating nice GUIs. We'll look at the overview of the design and then we'll also look at how the widgets interact with the code and the update function. So just a reminder with SSH, best practice is to use SSH2 with 2048 bits RSA. And if you can create a certificate and transfer that onto your remote host, then that saves you using passwords and it's more secure. Right, this is a design. So basically it's a form with some widgets. So you've got connect, which is a widget, aka a button. Then we've got a drop down. So the idea is to populate that with commonly used remote host IP addresses. There'll be a box where we can put in the username, and this is where you can manually add IP addresses. But the drop down here will actually populate that anyway. So you'll have a drop down of as many hosts as you want. You'll click on one of those in the pick list, and then that'll fill that in with the IP address and the port number. Then we'll SSH to a remote host. I've got a remote Linux server, so we'll connect to that. Within the code, we'll have some commonly used bash commands. We could have ls -a, df -h, tree, whatever. You can add as many of those as you want within this code if you want to clone it and modify it. The output will actually get returned and we'll display it on the form. This is the start of the project, so potentially you could take the response from the remote host, you could parse it, and then you could use that to have some sort of conditional display. You could have a text. Based on that text, you could then go off and do something else. So we'll get to all that in a second. You'll just need to add iced, cargo add iced to, and Tokyo as well. We use Tokyo because we want to run async because we don't know how long the response will take or the command to the remote host because that depends on the network. So it's network bound rather than CPU bound. I've installed libssh2. So it's a client-side C library implementing the SSH2 protocol. So this is installed on the computer that you're running the iced cargo, the Rust app on, not the host. I don't know if the host will also, not sure. I didn't have to install anything on the host. So this is the code. Update is, if you think of a game loop in a game, update is the loop which keeps checking for events, basically. And I've got an enum. I'll put a link to the code later on, and you can look at GitHub and see the full code. But I just wanted to pick out the bits that I think are most important. So the enum is basically button pressed, do nothing, and there's a few others. So within that enum, if the button's pressed, then we're going to match, and the result will be the SSH output. So we're going to set a variable to be the result of the command that we send to the remote host. So we're going to pass into our function called con, short for connection or connect. We're going to pass in the IP and the username. We don't need to pass anything else because we've already got the certificate set up. So this con function, the connect function, does all of the work, and that's actually inside another file now. So I've refactored it and split it up for maintainability, and it's called controller.rs. So we're using Tokyo, as I said, because we need the async because it could potentially take a while for the network. This code, so you've got the TCP stream, the handshake, etc. this is all the default code that comes from the SSH2 crate, I believe, that I used for connecting. So that's a cargo crate as well. I didn't mention that, but yeah, cargo add SSH2. So that, apart from Tokyo and the result, that's kind of the boilerplate code. Here, I'm now returning a result. So previously it was just returning unit, was returning, there was no arrow with anything here. So now we're returning result, which is a string. So we added Tokyo, or I added Tokyo. I've added this, so IO result string, and then at the end it returns the result, and the result then becomes the self.ssh output, which I then use to print back to the screen on the GUI. So if you're familiar with PuTTY, for instance, on Windows, that performs the connection and opens up the terminal. This actually saves you needing to have the terminal. So for instance, if you were on a machine which was maybe a Windows WSL Linux or a VM or something, you could actually run what I've written here. You could run that without actually needing access or admin access to any sort of terminal or shell. It's the GUI will actually display the output. So obviously there's security implications there, but if that's what you want to be doing, you want to be seeing the output from a remote host, then this is what you'll want. So this is all within view. So you've got update, which is basically if you imagine like the game loop, and then view. So view is what constructs the GUI. And here you can see you've got the previous, you've got the text input, the enter the IP import. So ultimately, this gets populated at the end with the output from the remote host. What else could we do? We could use this with a database, and we could store common IP addresses that we connect to, or host names. We could store popular vendor commands for switches, routers, firewalls from common vendors. We could put it in a serial KV database, because then we could embed that, so it would be all just contained within one single binary executable. The other thing that this could be used for is IoT. So you could have devices around your building, for instance, around your house, that you could have SSH connections to, which you could then remotely monitor, configure, adjust, turn your heating up and down, whatever, security cameras. And also, if you've got some proprietary software and you don't like the GUI, or there's a bug with it, or it's no longer maintained, you could write your own. The world's your oyster, really. Other things, you could remotely connect to a device, get some output, and then you could go off to ChatGPT or something and query the data, the response that you got back from your device. You could create a QR code of some data that you'd retrieved from a remote device. So then you can have kind of air-gapped security. GPIO, you could remotely control the device from the GUI. So in a second, we'll actually look at the GUI in action. So yeah, stay tuned. And just mobile, I gather that you can compile without too much work now, you can convert a Rust GUI or a binary executable written in Rust with a iced GUI. You can, without too much work, you can convert that to become a bit like a Flutter app for iOS. I don't know about Android. The code, github.com, RGGHGUISSH, you'll get the code. So if you like this project, don't forget, give me a tip on Lightning if you've got that capability. So let's look at the code. Well, let's look at the code running, more excitingly. Okay, so this is the code. I've put in the Ferris PNG, the crab, so that's what's given me the image, which is in the resources directory, which is at the same level as the source. I've added controller, as I've just discussed, main, as normal. And then because I've compiled it a few times, I've got the debug and release. So, and also we've got cargo. Let's just go and have a quick look at cargo. Got toml. So it's a bit dark, but there you can see I've got SSH2, Tokyo, full, iced, Rust embed. I don't know where that came from. I should take that out and see if it still compiles, but that's a job for another day. Right, cargo, run. Shouldn't take too long because I've already compiled it loads of times. It's a bit slow on this machine because it's not a newest laptop on planet Earth, so just bear with. We should get the GUI up here. Here we got it. So got connect button, choose a host. So I've just added 3. Only the top one is actually a real one. So as you see, as I choose the host, notice how it changes down here. My username. So I'm going to connect and it'll take a few seconds. I haven't added in any error handling or anything in case it panics yet, which is on my to-do list. So there we go. You might have seen this previously or seen some screenshots on my YouTube community page. But what is new is, do you notice this here, the Linux right-click Sunday? The GUI is now displaying the output from standard out from the SSH session. And that actually ended the SSH connection. So it connected to the remote host. It did ls-a, and then uname space -a. So there we go. We've got that output. Now we've got that output, we can do stuff with it. So as I say, you could go off to ChatGPT and you could ask it, tell me about it, or you could go off to, you could do whatever you want. For instance, you could, if you got the disk usage, you could do df-h, and then you could ask ChatGPT, at the current rate of progress, how long does it take until my disk gets filled up, whatever. But I think the power will lie within sort of doing stuff which is potentially air gapped, which is a good thing, or IoT. So yeah, IoT or air gapped, I think, is probably the 2 really good uses of this. On a corporate network, you've already got all your tools where you want to be using and connecting. But yeah, IoT, if you've got any remote devices, embedded devices that you need to connect to with SSH, or you want something which is very secure. And again, this code, the only crates it's using are iced and what was the other one? Mine's gone blank, but yeah, we use Tokyo, of course. Yeah, so let's just out of curiosity, let's see if I go into cargo. I'm not sure whether I need that embedded one. Let's try and run it again. Oh, sorry, my comment's bad. Right, let's run it again. I got a feeling I don't need that. I don't remember adding it in. We'll soon find out. Do you notice how that's taken the number of crates down to 298? Previously it was oh, we've lost it. So that's answered the question. We don't need that. So just to recap, cargo only needs, we're only using iced, SSH2 and Tokyo. So I think John Genset was very pointed out something really interesting, which was that particularly if you're writing software for a corporation, dependencies are a potential attack vector. So you want to keep the number of third-party packages to a minimum. So Tokyo is well known, and again, so is SSH2. So there we go. That's a quick update. And in future, I'll add some more stuff to this, but I think this is quite a good. It's now at a point where you could use it as your own boilerplate for doing something interesting. Um, I've put a dark theme on this. I've added the Ferris image, but you could put your own image. You could change the theme, and yeah, just look at how the update function updates and add your own extra items to the enum, which is when I talk about the enum, let's just go and have just one quick look at the source. Source. So iced makes quite a lot of use of the enum. So we've got my app message there. So when you add something else, you're going to need to, for instance, if you add another widget, you'll need to add an additional item to the enum. That's the struct, so that holds the data. The enum obviously just holds kind of the selection. That's my app, so that's when you create a new app. So those are empty at the moment. And if you wanted to add an extra widget, you'd start adding things here like radio buttons, checkboxes, etc. So you do actually need to add things in kind of under the enum, under the struct, and then because you've added something to the struct, you actually need to add it here because that's what creates the struct when you create a new instance. So import sandbox. In my previous video, I talked about the difference between application and sandbox. Ideally, you should use application when you start doing async stuff, and or if you start wanting to use multiple threads. The code's not the neatest, and yeah, it works. So that's the vector which supplies the choices for the pick list. So probably the best thing to do is clone my code and then just add to it and alter it and so on. So thanks for watching. Don't forget thumbs up, like, subscribe, all that because of the algorithms, all the things that the YouTube people say. I know it's really boring, but if you don't do it, don't say it, and then your videos never get seen. And yeah, there's not much point in doing any of this. But yeah, this is kind of the follow-on from the previous video. So if you've not seen the iced GUI video, which people seem to like, then have a look at that as well, because that was just kind of where I got started with it. And yeah, thanks for watching. Back soon.